Hi guys, this is the Horizon Progressive Jackpot Display Hacking video part 2. In the first video we got up to a test setup that looks something like this. Basically the commercial LED array board and a homebrew controller. This video covers the PGA Simulator 2000, which is present because I desoldered a couple of custom PGAs from the LED array. The new board has two jobs to do, the first of which, and the topic of this video, is the line scanning, which I have correct here. Despite the way the video looks, the lines are being scanned for each module from top to bottom. In the first video I just simply bridged these FETs to make every line of the display work simultaneously. That was a bit of a mistake. I haven't really messed up the board because all my solder blobs are across legs that are bridged internally anyway. Each of the 6 rows of 10 8x8 LED modules have 8 P-channel FETs switching their lines on and off individually. With them switching together you can see that I'm able to move columns, but I can't individually set pixels. The board has 8 of these totem transistor pairs, each of which is driving another 8 of the FETs. These totem transistor pairs are what were connected to the PGAs on the board, so I've got to replace that circuitry, and for that I'm going to use a decade counter. So long as I connect the lines in the order of its outputs, I'll be able to cycle the 8 lines with just a reset and a clock pin. This is a Texas Instruments quad half H-bridge driver which I've been using in a few projects lately. It doesn't get used in this video, but its purpose in the long run is to buffer the clock and latch signals for the serial line for all 60 of the LED drivers on the LED array board. The inverter outputs back at the controller are okay to run the clock and latch lines for one row of LED modules, but I don't trust them to fan out to the whole board. So I have the quad half H-bridge driver powered here, but not really connected to anything. The decade counter outputs are connected to the totem driver inputs. There was a nice power supply available back at the now redundant JTAG interface. And here we are back where we were earlier in the video, and that's how the lines are cycled with a decade counter. I'm shifting some pixels in here with an open latch. This one's a bit closer to the last example in the previous video, except I can do the line scan as well. And yes, control some pixels again. And look, screen burn. How unfortunate. And for the last example, I want to move those pixels out of alignment just so we can see something for the video. Not very useful for a dynamic display, but just so we can see some movement and know that individual pixels are being controlled. There we have it. All the data that I'm moving into the bottom row of modules there is a rotating 16-bit value, but I'm rotating it 9 times when there's only 8 lines, and that sets it out of alignment to make it move like that. Most of the modules on the display up the top there are getting no data, no latch, no serial clock, so that's just screen burn, and the wavy effect I don't see. I do see the burn though.